So projectile motion, and we did a little reading yesterday on projectile motion. Basically, any object that continues to move under its own inertia is considered a projectile. Okay, and so here's just a little example where you'd have to calculate when the little projectile lands in the bucket of water, and we're going to do something very similar to that. Okay. So what I want you to think about is the different types of projectiles that there could be. Okay, there's really only 7 types. There are 7 types of questions. Okay, and they all follow sort of the same rules. Okay, and basically you're going to be responsible for every type of question. And there really isn't too many trick ones or anything like that. There's nothing too crazy that I can do. You just need to know how to do 7 problem types. Okay. And the first one is simply up and down. And you've actually dealt with those ones in grade 11 already. Okay? Things that are thrown straight up and then come straight back down. Okay? So that would certainly be considered an easy one. Straight up and down. Okay? There would also be projectile on level ground. So projected straight out on level ground. Alvin, you should jot these down. This is going to help you with study. Okay? Is there anything else that you could think of on level ground? Any other way that you could project something? Is there any other way to do it? Like, it's either got to be straight up and down or at an angle, right? It can't be flat because then it's not going anywhere. It's just right on the ground, right? So how are we going to come up with 5 more different types? And the idea there is to include a cliff. Some sort of elevated launch position of some type. Okay? So, off a cliff, how could I project it? At an angle?
Sure.
Okay, so in other words, what you're saying is this thing? Chris? Okay, so this is projected off a cliff at an angle. And that one is sort of the big daddy. It's the toughest one. There's the most things going on there. But there are other ways that you can throw things off cliffs.
Dropping it.
Dropping it, that's good. Okay, I'm going to show that just by like a small little arrow.
What is that?
Drop, projected off a cliff at an angle. Projected off a cliff at an angle. I got to reorient my
Do we
pen.
throw it off the cliff? Or that counts as kind of same idea as the first one?
So what you're saying is this kind of thing, Troy, right?
Yeah.
You know what? I think you've discovered an 8th type.
Troy?
He's a genius.
I'll have to add that to the test. You probably won't see any of those, Troy, but that's a good one. I like that. Sorry? No, I'm just kidding. Okay, think about a cliff. What else can you do? Darren has suggested that we just drop it off a cliff, but we could also do what?
Throw it.
Straight down?
Sure.
Is that what you mean? Okay,
Oh,
so
watch you don't fall off the cliff though.
throw it straight down. Right? You could just like fire it straight down. Think about the movies and cars, driving along,
Drive over a cliff?
drive off a cliff, exactly. This kind of thing, right? Just horizontally projected, drive right off the cliff. Bring in Horatio and take off the sunglasses and figure out how far away the car is supposed to land or how fast it was going or something like that. And there's one more.
Go straight up and then have it go down.
Exactly. Up and then down, exactly. And really, I mean, you could say, well, if it's straight up, it's not going down the cliff, right? And therefore, if it's at an angle, well, then it's just like this one, right? But, so, anyways, we'll assume that maybe you reach out and throw it up, kind of thing, right? So, yeah, so it's thrown up and down. So, up and down off a cliff. And those are that's basically it. So we've got 1, 2, 3, 4, 5, 6, 7. Okay? They are all governed by exactly the same rules. The only thing that's different here are the initial velocities. Okay? And in fact, I've never done this, but I'm maybe just going to do this right now. Each one of these is going to be initial velocities. Let's talk about the vertical and the horizontal. Is there a vertical velocity on the up and down one? Going up, it's got to be vertical, right? So I'm going to put a little check mark there. There is a vertical there. Is there a horizontal? No, it's zero. Right? When you're projecting on level ground, is there a vertical and a horizontal? Yes. They both exist. If you're projected off a cliff, is there a vertical and a horizontal? Yes. If it's just dropped off a cliff, only vertical, no H, right? No horizontal. If it's thrown off a cliff, same thing, zero. If you drive off a cliff, no vertical, only horizontal. And if you're up and down off a cliff, only vertical and no horizontal. Okay? Those are the things you got to think about. And after that, the problems are all exactly the same. It's really quite simple. But you will see large problems, like 8, 9, 10 mark problems, because it takes that many steps to figure stuff out, right? But they're not particularly hard. Okay? They're not particularly hard. Okay, so that's a good little intro. Good? All right. So some basic ideas here, and if you want to jot these down, you can. If you want to abbreviate them, it's a good idea. If you want to just sit back and relax and print them out later, that's also just fine with me too. So some basic ideas here. Vertical and horizontal motions behave independently of each other. There's no relationship between vertical and horizontal. None. Okay? Only use gravity when you're dealing with vertical things. Gravity only acts vertical. If you can keep that straight, you're off to the races. Okay? So despite having a horizontal velocity, the projectile has the usual vertical acceleration of gravity. Doesn't matter whether I launch it straight up and down, at an angle, off a cliff. It doesn't matter. Gravity is minus 9.8, and it is only down. The horizontal component has nothing to do with the vertical. If you can keep vertical and horizontal separate, you're set. The other thing is that VH stays the same at all times. The downward acting force of gravity does not affect the magnitude of the horizontal velocity. Okay? Gravity does not affect horizontal. VH stays the same at all times. We're going to assume no air resistance. Any questions? Use the vertical velocity VV in all calculations relating to height of rise, time of rise, anything that has to do with the rise. You only use the vertical component. It is only the vertical component of the velocity which causes movement in the vertical direction. Okay? Only VV with height of rise, time of rise, anything to do with it actually going up.
Yep, buddy.
All right, so the question is, a bullet is fired from a gun and air resistance is negligible. The muzzle velocity is 120 meters per second. What do you think the word muzzle velocity means? It's the speed when it leaves the gun. Okay? Is 120 meters per second. How far away will the bullet land if it takes 2 seconds to hit the ground? So the bullet is doing this, right? And it's being fired sideways and it goes like that. How far away, what is the range if the muzzle velocity is 120 meters per second? So the horizontal component is 120. And it takes 2 seconds for it to hit the ground. How far away does it land? Nope, there's others. Yeah, I know. They're individuals.
You know why dinosaurs were, you know why people said they're dinosaurs? Cover up the existence of Pokemon.
Good theory, Justin.
Are you getting English again?
You're just reading it now, Troy?
I was half asleep.
Yes, the answer is B, 240. Not a trick question, Darren. It takes 2 seconds for it to land, but it also takes 2 seconds, and in those 2 seconds it's traveling 120, so it's going to go 240 meters. Mr. Bennett, you just told me that I'm only supposed to use, right, VV in all calculations related to height of rise, time of rise, and it fell 2 seconds. Time is the one thing that is both horizontal and vertical, right? Because the time it takes to fall is also the time it takes to go horizontally. That's the thing that is always the same for both. Okay, so yeah, 240. Okay. A question. A rock is thrown off a cliff at an angle of 30 degrees and a speed of 10 meters per second. At its peak, what is the vertical acceleration? So there's somebody throwing a rock off a cliff. The angle is 30 degrees. The muzzle velocity is 10, so like that speed right there is 10. At its peak, right there, what is the vertical acceleration? Correct answer is C. What is the vertical acceleration? Vertical acceleration does not change. It is always minus 9.8. Vertical acceleration is always minus 9.8.
Troy, did you get it right?
Okay, I'll give you another chance. This one asks for the horizontal acceleration. A rock is thrown off a cliff at an angle of 30 degrees and a speed of 10 meters per second. So same situations before, same guy, same place. At its peak, what is the horizontal acceleration?
Yeah.
The correct answer is 0. There is no horizontal acceleration. Horizontal velocity always remains the same. There is no horizontal. Now, if I ask for horizontal velocity, then that would have been this one, right? This one would have been horizontal velocity, but it's horizontal acceleration. Okay, here's a sample question. There's me driving my car off a cliff at the Grand Canyon in my stuntman days. Yeah. I went to the Grand Canyon once. I didn't want to get anywhere even near the edge. It just scares the daylight out of me. And of course, my buddy, the engineer, the science nerd, he picks up a rock and goes, "Let's see if we can figure out how deep it is." And he throws a rock out. It's like 1.5 miles deep or something. So you're not going to hear that rock land. And I was just worried that there was going to be some person down at the bottom and he was going to crank him in the head with his rock. Just throwing rocks off, trying to make it sound. Okay, let's get out of here before we. All right, you guys don't have this, do you? Anywhere? No. Okay. So just summarize that quick. We've got a horizontal velocity of 24 meters per second. It's going over a 45-meter high cliff. Okay. I mean, if all you want to do is just do this, right? So the VH is 24. So I'm driving my car at 24 meters per second, and I just go off the cliff. Okay. I would like you to tell me what is the time of fall. How long does it take for the car to hit the ground? And I'm going to make a note that says, calculate the time of fall for an object that is dropped straight down, and this is the same as the projectile. It doesn't matter that the car is going like that because it's going to take exactly the same amount of time to fall. You remember that picture we saw yesterday with the balls and the lines drawn across? Right? It's going to take just as long for it to do this as it's going to do that. So how are we going to do that? Okay? What is the vertical component at this point, at the start? 0. What is the vertical acceleration? Minus 9.8. We want to know the time. The distance is it 45 or is it minus 45? Does it matter, do you think? Well, let's just see. What formula am I going to use that has V, A, and D in it and also solving for T? I think D equals DIT plus 1/2 AT squared will work just nicely. So I'm going to go 45. What's my initial velocity? I'm dealing with vertical here, so my initial vertical velocity is 0. which is convenient because 0 times t is 0, plus 1/2 of minus 9.8 times t squared. Or 45 is equal to minus 4.9 t squared. And has anyone realized that I may have a problem? Like with the equation, I mean. You like that one, Calvin? I was waiting to see if anyone was going to. So I've got 45 over minus 4.9, and now I've got a problem because my left side is negative, and I've got t squared, and I can't take the square root of a negative.
Or you can't do a negative sign either.
Hey?
Negative sign either.
Thought you
45 is supposed to be negative, exactly. Yeah, because it's straight, it's down, it's in the direction, it's actually displacement, so it's actually minus 45, right? Okay, so I'm glad you figured that out. Nothing too challenging there. So a little over 3 seconds for it to fall. Now that we know how long it takes for it to fall, can we figure out the range? Can we figure out how far away it lands? Absolutely we can, right? We know the speed, we know the distance, or we know the time. So how far from the base of the cliff the car lands is what we want to find. This is known as the range. Okay? The horizontal component, VH, and the time in the air determine the distance. The horizontal component, VH, and the time in the air determine the distance. Okay, so it's going to be pretty straightforward. It's just going to be V bar equals d over t. V bar, same thing as the constant velocity, right? So it's going to be 24. My time is 3.03. Pretty easy to do. It was 24, wasn't it?
Yeah.
72.7 meters. Pretty far. Could you work backwards if you knew the height of the cliff and you knew how far away the car landed? Could you figure out how fast it was going when it left the cliff? And that might be something that an accident reconstructionist might be interested in, right? Is knowing that how fast the car was going. All right. What is his velocity at impact? Okay. Now you might say, well, it's just 24, but that's not true because the VH is 24. What's the VV? And it's not 0, right? It's being accelerated due to gravity, and so we need to find VV and then add them together to find the overall. So how am I going to find VV? Pretty straightforward. VF equals VI plus AT, right? The VF being my vertical component at the end. My initial vertical component was 0. I'm accelerating at minus 9.8, and my time is 3.03. So I'm traveling about 29.7 meters per second right here. And to find the impact velocity, I'm going to go v squared is going to be my 24 squared plus 29.7 squared. I get an answer of 38.2. Do I need an angle? Yep, it's velocity, you need an angle. Opposite over adjacent. So that's going to be 29.7 over 24. I get 51 degrees. And how would you describe that? Like, could you go like east, 51 south? Is that how you would describe it? Probably not. You would say BTH, below the horizontal. 51 degrees below horizontal, BTH. That's pretty simple, pretty straightforward. No? You could too. It's going to be. Sounds cool to you. Really, what did I do? What have I done? Have I shown you any new formulas, anything particularly new here?
No.
All I've done is now introduced a problem where it's not just sort of one dimension, it's two dimensions, but as long as you keep them separate, it's really just review from unit number 1, isn't it? Go. One last question to see if you get it. One last question. Everyone's favorite late night host, back in the good old days when he was even funnier than he is now, used to throw watermelons off the city building. He did it like weekly. He would throw stuff off buildings, you know, TVs and stuff. What are you doing, partner? Get your clicker. Oh. If he throws a watermelon off a 25-meter building at a speed of 1.5 meters per second, how far from the base of the building will it land? To 1 decimal point. So now you got to do exactly what we just did. Put it all together. It's 25 meters high.
So it's the impact thing.
It's 1.5 meters is the horizontal speed, and the question is how far from the base of the building. So we are solving for the range down there. And then I have some YouTube video of it actually doing it for your enjoyment. Correct answer is 3.4. 7 of you got it. Let's see what other people got.
No, I got it right. This is mine, I got it wrong.
This is by no means an indication of your worth or anything. I just want to see what other answers were given. Okay? So 1.5, 3.5 I would accept, Lindsay. That's probably pretty close enough, right? Okay. There was a couple of ones that, so shall I do it?
Do what?
Do the question? We're good? No, I don't want to waste time. What I want to show you is a video.